Hey everybody, this is Larry. This is me going over Q3 of the recent Leetcode bi-weekly contest. Make some divisible by P. Hit the like button, hit the subscribe button, join me on Discord, and let me know what you think about this contest. So make some divisible by P. So this was conceptually not a tricky one, but I took 13 minutes, so with 2 wrong answers. But some of that was just my fundamentals were not good on the implementation. Basically, I forgot some edge cases, but this so for this problem, the prereq would be dynamic programming on the prefix sums. So that's the way I would phrase it, and I think this is actually a problem that comes up in different places on Leetcode. It's just that this is rephrased in a different way. So actually, I do like this problem, even though I muck up pretty badly. I did pretty poorly. But basically, the idea is that whenever I see something like smallest subarray, it makes me think about a couple of ways to do it. Some of it is okay. It's about keeping or removing, right? And for this problem, I actually end up using just removing the smallest one. But the idea is that, okay, given the total of the array, we want to remove one chunk of it where the sum of the chunk is equal to whatever the total is minus the p value, right? For example, in this case, the sum is 10 and p is equal to 6. So then our target would be to remove a subarray that's equal to 4. And once we reduce that to that problem, this is actually standard-ish, minus some edge cases which I muck up it. Because, okay, so like I said, I took the total, which is the sum of the arrays, and I took target as equal to total minus mod p. And then now, if target is 0, 0, we just return 0 because I'm lazy. But otherwise, we go through the entire array with the prefix sum dynamic programming. If you're unfamiliar with that, then there are a couple of problems. I'll link below on problems that you can practice with, or if you are familiar with, let me know. But the idea here is that basically you take a prefix sum, which is the current here, you multiply by p, and then you try to find the number such that your prefix sum minus the target is equal to p. So again, this requires knowledge of the prefix sum, but basically you have some. Okay, let me actually print out. So basically, how I like to explain this is just go by each step of the way. Let's add some more numbers. Right. So we have this array, right? And then basically, if you step through it, and we could probably, print looking for target. And this is actually what I like to do sometimes when I am debugging as well, is that I would like to print so that, like, I like to do the visualization in code. I know that some people like to draw, and I do that as well, but sometimes I like to look at the visualization of that is so that you can kind of just look through your code and see what is going on. So basically, we're looking for the target 1. So the current sum is 0, right? If the current sum is 0, then we're looking for 1 in the index, which it doesn't exist. If it looks for 3, then looks for 2, right? Or like if the current sum is 3, then looks for the answer, the number 2, because that means that in the prefix sum, everything to the left of that would be 2, so then the things in between would be 1. So that's how you kind of do the math, and that's how I did it with prefix sum. I know that this explanation is a little tricky if you don't have the prefix sum dynamic programming background because this comes up a few times, and I really should have done this a little bit faster, to be honest. But yeah, like for example, now it doesn't find any, so it looks for 2. It looks for 1, it doesn't find any. So 4, right? So now that the current sum is 4, it tries to find the number 3 because it knows that what does this 3 represent, right? This 3 represents the sum from 6 to 3 mod p, which is mod 6 in this case, right? Where the 4 represents these 4 numbers, the sum of these 4 numbers. And so 4 minus 3 represents the sum of these 4 numbers minus the sum of these 2 numbers. So let me also kind of put it here. So that means that, yeah, we basically take this minus this, right? And this means that everything in between will be 1 mod 6, and from that's basically how we figure it out. And because this is 1 mod 6, we know that taking this out would mean that the total mod p is equal to 0, which means it's divisible by p. So that's kind of the algorithm. It's a little bit tricky to understand. Definitely play around with prefix sum, and yeah, as we dig through it, we step by step, we try to find the smallest array to remove. And in this case, we keep track of the index of the previous of the current index. So we keep track of 3 as an index 1, and this is an index 3. So that means that 3 minus 1 is equal to 2, which gives us the subarray that we need. So then, and so that's what this line does, and this just gives us this gives us the 2, and this gives us the smallest subarray that we can get away with. So I had some typo during the contest, or I just one prefix sum that I've been messing this up lately is that you should start with a 0 in the prefix sum so that you can remove the prefix. Otherwise, you always have to remove the first number, right? So that's kind of the one thing that I got a WA on. And then the other thing was that I just, instead of taking the smallest subarray, I took the largest subarray because I was silly. And you can see how I make those mistakes as I do the contest next, or do the problem during the contest. So what is the complexity of this? Well, the previous is a hash table, and we only have 1 entry per number in num, so it's going to be only 10, up to 10 to the 5th, so it's linear space. And this just, this does all of 1 operations per element, because these are just the most expensive are the hash table lookups, so it's still all of 1. You can play around with it. But so that means that this for loop is O of n. So that means that this algorithm is O of n. So linear time, linear space for this algorithm for me. Yeah, let me know what you think. Hit the like button, hit the subscribe button, join me on Discord. Let me know if you want me to do a tutorial on prefix sum, or at least prefix sum dynamic programming. I might do one. It is something that I'm interested in. And yeah, and you can watch me solve the contest problem next right about now. Let's see. No, wait, that's not true. This is not right at all. System. No, I think I misread the problem. Oh, right. Not a good day, I guess. What am I looking at? Oh, yeah, oh man, just one of those days. Not really thinking through. This is no longer true. I changed it again. I'm really bad today. Yeah, thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord, and let me know what you think. I'll see you next problem. Bye bye.